That skill presents variance and standard deviation. The measures of central tendency, that is the mean, median and mode, may not always reflect the true nature of data. For example, two data sets having the same mean can be completely different. Consider this. Let's have two groups of students, Group A and Group B. And each group has, let's say, 9 students. And let's also say that the test scores of the students in Group A are something like, let's say, 55, 60, 65, 70, 75, 80, 85, 90 and 95. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. So if you want to find the mean or the median in this case, it's going to be this 75. In this case, the mean is the same as median because the numbers are equally spaced. Now for the students on Group B, 9 students, same number, let's say the scores are like 71, 72, 73, 74, 75, 76, 77, 78 and 79. So the mean and the median on Group B is also that same number, 75. Now if you only find out the mean or the median in this case for the two groups and compare, you'll probably think that okay, the two groups match each other. But as you can see, the data are completely different. In Group B, the data are clustered around the mean, to indicate that in Group B, all the 9 students are more or less somewhat equal as far as this particular subject is concerned, for which we have the test score. But if you look at Group A, there's a 55 and 60, and there's also a 90 and a 95. So the data is much more spread across, even though the two groups have the same mean or the median. Thus, to describe the data accurately, we need to know the extent of the variation. And that's exactly why you want to learn about a couple of new concepts called variance and standard deviation. The standard deviation is denoted by the Greek alphabet sigma, and the variance is actually the square of the standard deviation, so that's sigma square. Let's say we have a set of numbers x1, x2, x3, x4, and I'll just keep it to x5. So we have 5 numbers. And let's also say that the mean of this set of numbers, the mean doesn't have to be a number from this list. So let's say the mean of this set of numbers is m. We find each of the values m minus x1 and then m minus x2, m minus x3, m minus x4, m minus x5. That is, we find out how far is each data value from the mean. And then we square each of these and add them up. So we do this, square of this, square of this, square of this. And then, like I said, add them up. So we get a sum. Let's name that sum. Now if you divide this sum with the number of numbers, in this case I have picked 5 numbers, so I'm going to divide with 5. That's what you call the variance of this set of numbers. The standard deviation, like I said before, is just the square root of the variance. So we could say standard deviation is equal to the square root of the variance sigma square, and therefore this is denoted with the letter sigma. Let's now go back to that example I was referring to and try and find the standard deviation and the variance of the two groups. So here are the numbers, and let's talk about the variance first. So we want to find the variance of group A and group B. Now the mean in this case obviously is 75. When the numbers are equally spaced, the mean has to be right in the middle. If not, you just need to do one extra step to find the mean. But we are going to assume that we have done that step, and it's safe to say that the mean is 75. So to find the variance, we are going to subtract each of these numbers from the mean. So we do 75 minus 55, square that, plus 75 minus 60, square of that, plus 75 minus 70, square of that, plus 75 minus 75, that will be a 0, but let's just write that down for the sake of completeness, plus 75 minus 80, square of that, plus 75 minus 85, square of that, plus 75 minus 90, square of that, plus 75 minus 95, square of that. And all of that, the sum that we get, has to be divided. So this must be divided with the number of numbers, which is 9. So we have a 20 square plus, this is a 15, so we have a 15 square, plus this is a 5, so we have a 5 square, plus a 0 square, plus again 75 minus 80 is a negative 5, so when you square that, it becomes the same as 5 square. 75 minus 85 is negative 10 in the same way, so if you square that, it becomes square of 10, same thing, plus 15 square and plus 20 square. All of that again divided by 9. And these are big numbers, as you can see. 20 square is 400. So we have a 400 plus 15 square is 225. 5 square is another 25. And then of course we have that 0. And then again a 25 for this 5 square. I think I missed subtracting the 65 from the mean. So we do have a plus 10 square here. That's that 75 minus 65 part. I'm glad that I figured that out. So in between the 225, which is 15 square, and the 25, which is 5 square, we have a 100. That's 10 square. And a plus. Then we have a 25 and the same thing repeated. 100 plus 225 plus 400. And all of that divided with 9. And that is equal to, if you add them up, you get 1500 divided by 9, which is equal to 166.67 rounded to the nearest hundredth. And the standard deviation, which is the square root of the variance, is going to be square root of 166.67, which is equal to 12.91. How about the variance of group B? The mean is still 75, the same as the mean of group A. But if we go on to find the variance, so we need to do 75 minus 71 square plus 75 minus 72 square plus 75 minus 73 square plus 75 minus 74 square plus 75 minus 75 square plus 75 minus 76 square plus 75 minus 77 square plus 75 minus 78 square. One more term, plus 75 minus 79 square, and all of that divided with 9. 75 minus 71 is only 4, so 4 square is 16. Let me just write down 4 square now. 4 square plus 3 square, 75 minus 72 is 3, plus 2 square. I think you already started finding the difference. We are at 20 square, 15 square, 10 square. And on this one you only have a 4 square, 3 square, 2 square, 1 square. Obviously this is a 0 square. Again, 75 minus 76 is negative 1, and if you square that, it's the same as 1 square, plus 2 square, plus 3 square, plus 4 square. And all of that would just add up to, we have 16 plus 9, which is 25, 25 plus 4 is 29, plus 1 is 30, so you have 30 on one side and 30 on the other side, that makes it 60. And 60 divided by 9 is 6.67. Look at this, 166, and this is only 6. And the standard deviation is the square root of the variance. So it's the square root of 6.67, which is equal to 2.58. So if you compare the variance of the two sets and the standard deviations, you will come to realize that the data in group B that has got a smaller variance and standard deviation, the data has to be a lot more clustered around the mean. On the other hand, group A that has got a larger variance and standard deviation has to have the data spread far and wide as compared to the data in group B. One final food for thought. Any idea why we square these up and then take the square root in the end? Well, if we didn't square these up, then we would have a positive 20 on this side and a negative 20 on this side. Similarly, we would have a positive 15 on this side and a negative 15 on this side. So in the end, if you added them up, you will get a 0. And that would not be a good indication of the variance of the data. So to negate the effect of the negative numbers on the sum, we first square them to get an all positive sum, and then in the end, we take the square root to find the standard deviation.